Hi there, and welcome to the whitchermath channel. I know I've got tons of videos on this playlist for equations and expressions, but maybe it's time for one that's a little more explicit. Okay, so we've been dealing a lot with these they're called tile patterns. They show up in a variety of textbooks, and I happen to know from personal experience they show up in a lot of standardized test situations. You know, sometimes they look like little popsicle sticks, or they might be an array of circles or something. But the bottom line is you're probably going to run across some form of a visual pattern frequently, here and there, maybe not frequently. So let's go through this little worksheet that I created for my class and see if we can help this make a little bit of sense to you. The idea is here that we can generalize all of these patterns, meaning if you can get what's happening here, you could apply it in a lot of different situations. So in tile patterns like these, we use the letter, it's going to be X or Y. What's it going to be? To represent the blank, and the letter blank, another X or Y. Okay, well, we use the letter X to represent the figure number. And we use the letter Y to represent the number of tiles in this case. Maybe when you run across it, maybe it's number of circles, number of sticks, whatever. Okay, excuse me there. To write the equation for these things, we need to know how many tiles are in figure 0 and how much each figure changes. Okay, which can either be plus for grow or minus for shrink or reduce. Okay, here, let me give you an example of what we're talking about here. So here's a series of tile patterns, just like are shown up top there, and I've shaded in how they change. Each one changes by 2 in relation to the last one, and they change in the same way, in a predictable pattern. So as you move from left to right, 2 are being added to each one as we go that way. So that's called the rate of change. Okay. So it makes sense also that if you go backward from right to left, that 2 squares would be taken away each time. This is a way for us to figure out what the next patterns might have in them. So this means figure 0 would have, well, here it's got 1, 2, 3, 4, 5, plus 2 makes 7, plus 2 makes 9. So if I'm going to go back this way, it would make sense that figure 0 would have 3 tiles. Okay, the number of tiles in figure 0 is called the initial value. Later on in algebra, you're going to learn that that is the y-intercept. Okay, we can use those words interchangeably here. They can be substituted for one another. Okay, so in y equals mx plus b form, x represents the figure number and y represents the total number of tiles. So up above here, please notice that's where we got those answers. Okay, x is the figure number, y is the number of tiles. So back down here to the bottom, x is the figure number, y is the number of tiles. M is the rate of change, and b is the initial value, right, which we just notice is going to be called the y-intercept later. Might as well tell you now, spoiler alert, that rate of change will be called slope later. So here we go to summarize what's going on here. Using the information on this page, we're going to write the equation in that format, y equals mx plus b, to represent this series of tile patterns. Here we go. Number of tiles is the rate of change. What was the rate of change? Right there, 2, times the figure number, that's x, plus the initial value, or how much was in figure 0. Hopefully you remembered figure 0 had 5. So there's our equation, y equals 2x plus 5. Now if you think of it in terms of a sentence frame, fill in the blank just like we did, it's a way that you can solve any of these types of problems, not just the one on this page. So I hope that helps out a little bit and kind of just breaks it down step by step for you. So when you're looking at these geometric patterns, there's an easy way to get it done if you keep in mind that rate of change, known as the slope, and initial value is the y-intercept, and maybe that'll help you get it done. Thanks for watching, and stay tuned for more exciting math action on the WhitcherMath channel. Bye for now.